Myself, I am Jyotimani, Assistant Professor, AC Department from KSR College of Engineering. We are going to see about E-plane T. So E-plane T is one of the most popular power divider. So this is a microwave component. So this component is used to divide our powers in the any place. So this E-plane can construct the two ports, that is like named as port 1 and port 2. Then additionally one port is added into or affixed into this port 1 and port 2 amps. So this port 1 and port 2 is called as collinear arm, and port 3 is called as, that is, difference arm or series arm. So this difference arm and series arm, are also called as series arm. This is used to divide our power. So this is the construction. So this construction is port 1 and port 2 is name it as collinear arms, and port 3 is name it as side arms or difference arms. So the main ports are port 1 and port 2. Suppose if you are giving input in port 1 means the output will be taken from the port 2 and port 3. So similarly, port 2 is act as a input port means you will get the output from port 3 and port 1. So the scattering matrix is called as S23, that is equal to S13. Another one input we can given to this port 3 means that port 3 will be that same power will be appeared in the port 1 and port 2 in amplitudes, that is 180 degree opposite phase. So additionally another one combination we can give the two incident wave, that is also called as two input waves, is fitted into this port 1 and port 2. You will get the difference output from port 3. That's why this is called as a port 3 is called as a side arm or series arm or difference arm. So you can explain this same power dividing into this form of scattering matrix. So let us go to start derive the scattering matrix. So here we are seeing this 3-port junction. So this is called as a T junction. This T junction having 3 ports. That's why we can classify or we can derive the 3 cross 3 matrix. So possible 3 ports means you will get the 3 cross 3 matrix. So S matrix is defined as S11, S12, S13, S21, S22, S23, then S31, S32, S33. So scattering matrix is then port 2 and port 1 is the out of phase, that is 180 degree phase shift. That's why the scattering matrix we can define or derived from S matrix S23 equal to minus S13. So both amplitude will be same but in opposite phase. That's why this port 1 and port 2 having 180 degree phase shift. So our T junction port 3 is perfectly matched means you will get the diagonal elements, that is port 3 S33 equal to 0. So any one of the port will be perfectly matched means that then reflection coefficient will be 0. The reflection coefficient means S11 or S22 or S33. Then using symmetry property. So symmetry property means you will get the, suppose if our junction is lossless junction means you will prove the symmetry property. So Sij equal to Sj, I not equal to j. So one is row, another one is a column. So Sij equal to Sji means from our 3-port networks you can derive the or you can equate the sum of the elements, that is scattering parameters, S12 equal to S21, another one S23 equal to S32, then S13 equal to S31. So these all the values will be substituted in the general S matrix. So you will get this general S matrix changed into equation number 5. So next unitary property. So unitary property means S matrix complex with S matrix both are multiplied, that is equal to unit matrix. So now I will write the equation number 5 matrix into same equation number 5 in the complex conjugate, that is equal to unitary matrix. So first I will take it as row 1 multiply with the column 1. So row 1 is S11 multiply with S11 star plus S12, then S12 star plus S13 multiply with the S13 star, that is equal to 1. So S11 then S11 star, we can write S11 squared plus S11 squared is also another one is equal to S12. So S12 already you can define from this equation number 3. So that equation is 7. Then another one combination is multiply of rows and columns R2 and C2, that is also equal to unitary matrix, that is unit value. Then another one combination is R3 and C3. Then finally you can cross row and columns, that is R3 and C1, that is also equal to unitary matrix. So equation number 6 and 7 you can equate because of right hand side the both values are 1. So you can equate and simplify. Finally you will get S11 equal to S22. So that is name it as equation number 10. Then another one, from equation number 8 you will get 2S13, that is squared R S13 equal to 1 divided by root 2. So this is the main value of scattering parameter. Finally from equation number 9 you will get the values of S11 equal to S12 or that is also equal to S22, because already we have know that S11 equal to S22. So all values are incorporated into this your general equation, that is equation number 6. So from equation number 6 you will get the final value of, that is scattering value of S11 equal to 1 divided by 2. So that is equation number 13. This 13 from equation number 10 to 13 it will be submitted or substituted into general equation of your equation number 5. Finally you will get values of the 3 cross 3 matrix for E-plane T. S matrix equal to 1 divided by 2, then 1 divided by 2, then 1 divided by root 2, then 1 divided by 2, 1 divided by 2, minus 1 divided by root 2. Then third row is 1 divided by root 2 minus 1 divided by root 2, 0. Then this same S matrix can be simplified in the form of, you will take it as 1 by 2 in the outside means you will get the simplified form. So S matrix, that is general format is B matrix equal to scattering matrix into A matrix. B is generally name it as output matrix or reflected wave matrix. Then S matrix is a scattering matrix, then multiply with the A matrix. A matrix is the input matrix.